just like regular frequency, our units for pulse repetition frequency are going to be in hertz, guys. Hertz. Or hertz, or what else? What else could it be in?
Second.
Pulses per second. Pulses per second. Okay? So we're good with this right here. We're just going to use hertz, okay? We're just going to use hertz because that's going to, because the questions I asked you on the little worksheet, they're asking for stuff in hertz, okay? All right? So again, that's the number of pulses transmitted into the body each second. All right? The typical values for that are going to be 1,000 to 10,000 hertz. Okay? So that's going to be 1 to 10,000 pulses per second that a transducer is emitted into the body. That's a lot, right, guys? That's moving. That's moving so fast. That's why I say I can't demonstrate that. I can't even move that fast to demonstrate 1,000 to 10,000 anything per second. You know, I can't even blink that fast. I'm trying to think. I used to be able to run that fast back in the day. You know, when I was doing a little track. You didn't know I held the world record, did you? All right. So just like the PRP, also determined by the source initially, right? Because it's already determined with different transducers, right? All right. So initially, it's determined by the source. But just like the PRP, because they're inversely related, right? When we change the depth, we're also changing the pulse repetition frequency. All right. When we change the imaging depth, we're also changing the pulse repetition frequency. Bang. All right. So yes, the PRF is adjustable because when we change our depth, we're changing how often the machine is sending out pulses. Okay. So if I'm looking at a shallow image, then look, let's say these are just, let's say this thing right here, this line right here, that's 1 second, right? Let's say that's 1 second. Which one of these would be more frequent, the shallow imaging or the deep imaging? Shallow, right? Because I'm able to send out another pulse sooner because my reflected sound waves are coming back a lot faster. Okay? So that's going to make my pulses occur more frequently. Okay? So if I'm looking at something deep, I'm not able to send another pulse out until I get my reflected sound waves back. Right? So if I increase my depth, then I'm going to be decreasing my pulse repetition frequency. Because those pulses aren't going to be able to go out as often. That's why it is inversely related to the imaging depth, guys. Our pulse repetition frequency is inversely related to the imaging depth. It's also inversely related to the pulse repetition period, right? Think about it. If we're able to, this right here, we have a shorter PRP, right? But we also have more pulses occurring per second. How many pulses occurring per second in this on the shallow imaging? 5 pulses per second. What can we also write that as? If I'm asking for what's my PRP, what's my PRF? 5 hertz, right? Because that's our units. 5 hertz. So our PRF right here on this one is going to be 5 hertz, right? Because I'm telling you that it's occurring in 1 second. Okay. So our PRF on the top one is what? 2 hertz. 2 hertz, or 2 pulses per second. All right. So our PRF right here equals 2 hertz. Because I have 2 pulses occurring in that 1 second, okay, with my deeper imaging, because I have to listen. So same thing, just like the PRP. When I change the imaging depth, that's how I'm controlling the PRP and PRF. So just similar to like last chapter, even though they don't relate at all, period and frequency are always going to be inversely related. Okay? Period and frequency are always going to be inversely related. But just like normal period and frequency, PRP and PRF, they're inversely related, but they also have that special relationship. What is that, Samini?
PRP and
PRF. What is that special relationship they have with each other?
inversely.
What's that special relationship,
Inversely.
Sophia?
Between PRF
And PRP. They're also reciprocals, right?
Reciprocal.
Because period and frequency are reciprocals as well.
Yeah.
PRP and PRF are also reciprocal.
I remember.
So,
I don't know how to say it.
Reciprocal.
for our formulas, I'm just gonna write it big right here. PRP times PRF
Equal 1.
equal 1, right? Because that's what reciprocal means. That's what a reciprocal is. When you multiply two numbers together, they equal 1. But that also means that PRP equals 1 over the PRF, right?
Yep.
And vice versa. PRF equals 1 over the PRP. We're good there, guys? I know it's hard to see. It's just that I would have to walk so much to turn that light on every time, and then y'all may have a seizure if I have to keep cutting that light on and on. Where's my clicker at? Where's my clicker? Where does that come? Bang.
It's triple P.
Triple P? Where's triple P? Oh, my fault.
You did it again, but this time it's okay.
I did it where? Ah! Thank you, Lauren. Thank you, Lauren. Keeping me on point. All right? So, PRP and PRF, they're reciprocals, right? So, you multiply those two numbers together, they're going to equal 1. PRP also equals 1 over the PRF. So, if my PRP is 100, what's my PRF, Myra?
0.1.
1 over 100. Hertz, though, right? Don't forget my units, guys. Don't forget my units. Okay? So, again, our PRP is 1 pulse duration and 1 listening time. 1 on time, 1 off time. Remember, that's the time it takes from the beginning of one pulse to the beginning of the next pulse. All right? Our pulse repetition frequency is how many pulses we're sending into the body each second. All right? What's my PRF on here? 3 megahertz, right? 3 megahertz. 3 megahertz. Because, and again, that's assuming that this is 1 second, right?
Mm-hmm.
What if this was 2 seconds?
1.5.
1.5 megahertz. Okay? We clear on that, guy? I know I'm just throwing math at you. I'm not going to be act like that. I'm just trying to make sure that we have a grasp of what's going on. Okay? Apologies. I said, I don't think you speak for everybody in this class. And I'm going to leave it at that. All right. So, when the system is imaging at shallow depths, the PRF is higher, right? I'm able to send out more pulses more often because the listening time is shorter. Okay? Because remember, all we're changing when we're changing the depth, and when we're changing the depth, we're just changing the listening time. That affects both the PRP and the PRF. Okay? When I'm imaging structures that are deeper depths, the PRP is a lot lower, right? The frequency of those pulses per second is a lot lower because it's not able to send out the next signal, the next pulse is fast because it's listening for it to transmit, listening for it to come back to the transducer. Okay. All right? So, again, guys, just like PRP is unrelated to the period, pulse repetition frequency is unrelated to frequency. Okay? Because when we're talking about frequency, we're talking about cycles. When we're talking about pulse repetition frequency, we're talking about pulses. Okay? Wow, look at that. What's on right here? Okay? It is only related to the depth of view. When I change the view, I'm changing my pulse repetition period. I'm changing my pulse repetition frequency.
I mean, inversely.
Inverse related, absolutely, absolutely. Because when I'm looking at shallow depths, my PRF is going to be higher. I'm able to send more. My depth is shorter, it's shallow, but my PRF is higher. That makes them inversely related, right there. Inversely related. So the one goes up, the other one goes down.
Like just remember, like I think it's my weight. Like if I remember PRP and PRF, so I just remember one thing and the other one is gonna be inverse.
That's a good way too. That's how I remember. I always remember the easiest way I can.
Yeah.
But I want everybody to have their own system. Have your own system. You know, I just kind of related back to the last chapter. I'm just looking at the last word, really. I know period and frequency are inverse related.
Yeah.
Right. Just know when we're talking about PRP, we're talking about pulses. We're talking about PRP, we're talking about pulses. We're talking about period and frequency. We're talking about single cycles. Bang, bang. Okay?
And you say PRF is unrelated to frequency, but related to depth.
It's only related to the depth because when we change the depth, we're actually changing the pulse repetition frequency. Okay? When I increase my depth, I'm decreasing my pulse repetition frequency because I'm not able to send pulses out as frequently. Okay? Because I have to wait a longer time for the sound to come back to my transducer. Okay? You got giving those eyebrows. You have an eyebrow like, interesting.
Because it's determined by the sound source and the depth, but then when you
That is it. Complete your sentence. Complete your sentence. I want to make sure we got a good
we're
grasp.
adjusting the depth, how is it determined by it also?
It's determined by that because the sonographer has a control over the pulse repetition frequency when we change it. But initially, the pulse repetition frequency and pulse repetition period is already set within that transducer. But when we change the depth, that's why you have it both the source initially, just like God, what was that last chapter? Initially, the wavelength. The wavelength also initially determined by whatever the source, but also it's affected by the medium. Okay? Okay? But instead of it being affected by the medium, we're actually changing it when we change the depth. When I increase the depth, I'm changing the listening time. I'm either making it listen, or if I'm increasing, I'm making it listen a lot longer. Right? Because I have to travel deeper into the body.
Okay.
Okay. The depth of view describes the maximum distance into the body that an ultrasound system is imaging. All right? That's what the depth of view describes. So, you know, just like it has a picture in there, guys, of the depth of view. You see, we know what the depth is, right? Because we see the little white marks on the side of the right side of our image, right? That's our little depth scale. If I say increase it, and you're on 16, I want you to go deeper into the body to say 20, right? So when I'm in the lab and I instruct you guys, I say, man, increase your depth. I want you to go deeper into the body. When we go deeper into the body, we're increasing our pulse repetition period. We're decreasing our pulse repetition frequency. Okay?
When you say increase, the picture is like zooming in.
No,
It was kind of out of.
Zoom is something completely different. Zoom is making it come like this. Depth is making it go deeper.
She meant like
I know, but I know that, but I just didn't know how to use the word. When you look at this painting, you say, okay, she said that. I don't like those.
Meaning you make it, the image is going to be going up.
So it's gonna get smaller.
Yes,
The
you
number
can say
of
that. If you increase the depth, you're sending whatever's on there closer to the near field. You're sending it closer to the transducer. You increase the depth, meaning that my image is going to be going up like this. When I decrease the depth, my image is going to be coming down, appearing a lot bigger.
the number gets, like when you increase the number, it will be bigger.
Right, absolutely, absolutely. When I increase the depth, the number is going to be a lot bigger. So
And your
I'm
picture's smaller.
just going to draw an example right here, guys. That's the transducer. Bang. Bang. This one right here, this is going to be, I don't know, 20. This is going to be 5. So I'm just going to draw my my liver tip, okay? My liver tip is gonna be like this. Left liver tip. That's what it is at 5 centimeters. That's what it will look like at 20 centimeters, right? Right? Because I'm going deeper, I'm going to make whatever's in the near field be even closer. Okay? We're good there, guys? Was that a good
No,
answer?
yeah, that was good.
Okay, okay.
So when you tell us to decrease the depth,
I want you to make the image appear bigger. Like for instance, you guys a lot of times when we're grading your lab test, for example, a lot of times you guys are showing me the aorta, a lot of the aorta on your left liver. Remember I said it's just a landmark. I don't need to see the whole thing. You don't have to cut on harmonics to show me the aorta because we have a separate aorta image. Okay? So I may want you to decrease your depth because I don't need to see all of that in the deeper portion. Right? So, like, let's say this was we're just going to say this is my aorta. I'm probably not going to see it. It's probably going to be off my screen, or right here. My aorta is probably going to be right there.
Too small.
I don't need to see all of that. I want you to decrease my depth so I'm just seeing the left liver. Okay?
With the oil, but you don't have to be too deep.
okay.
Yeah, I don't need to see I just need to see a part of it. I don't need to see the whole aorta like we're doing the distal aorta. I don't need to see all of that. Because we already have a separate image specifically designed just for that aorta. So that's when you want to go in and clean it up, hit your TGCs, your harmonics. Because I'm seeing a lot of people put harmonics on when they're showing me this image. I don't care if the aorta has a lot of noise in it. I could care less because that's not my focus. I want to see the left liver. Okay? Ooh. So PRF, post repetition frequency, and the imaging depth are inversely related.